Welcome back to round 2 of studying for static electricity. And yes, I am a little bit punchy. Haven't slept enough. What I'm going to do this time is 2 more different problems, one using Coulomb's law, and then another that's a very conceptual one about plus and minus charges. So the first one, the type of question you might get is, might give you 2 charges here, A and B, and then it'll give you another set of charges, C and D. And I'm just going to make up some numbers. Let's say this is a plus 14, and this is a minus 8 charge, C is a minus 2 charge, and D is a plus 30. And if this is a distance r away, some unknown distance, we don't know what it is, we're just calling it r. Let's say this is a distance 1/2 r, not to scale. What I'm going to ask you to do is rank, again, this is a ranking question, rank the force on A. So what does A feel from B? What does B feel from A? What does C feel from D? And what does D feel from C? So rank the force that each of these 4 individual charges feels due to that other charge that's close to it. In this case, if you wanted to, you could make up numbers. You could say that R is, 100 meters or 100 centimeters or whatever, and this would be 50. And then you could figure out all the numbers using Coulomb's law and then just rank them. But I don't care what the actual numbers are. I just want a ranking. I just want to know, is this one bigger than that? Is that one bigger? So if I go back to Coulomb's law, the force is K, Q1 times Q2 over R squared. Well, the K is a constant, so that doesn't matter for ranking. We can ignore that. Q1 is the charge 1, Q2 is charge 2, R is the distance between them. So if I do the force of A pushing on B, or the force of B pushing on A, or is it pushing or is it pulling? Those are going to attract each other because they're different charges. So these are pulling each other together. So the force would be K times charge 1, 14, times charge 2. And again, I don't care about that negative. I'm just going to ignore that over R squared. The force of B on A, K times 8 times 14 over R squared. Well, yeah, those are the same, aren't they? And you should remember this from first semester physics. This is Newton's third law. The force of A on B has to be equal and opposite to the force of B on A. So the size of the force needs to be the same, and the direction needs to be opposite. Is that true? Well, this is getting pulled to the right, this is getting pulled to the left. Yeah, but the size is going to be the same. So if I don't worry about the K or the R, this is just going to be, well, it's 14 times 8, which gets me 112. This is 14 times 8, which is 112. Okay, so how about C and D? So the force of C on D and the force of D on C. K times charge 1 times charge 2 over distance squared. Okay, and then K times charge 1 times charge 2 over distance squared. Again, I'm just going to ignore the K and the R because those are going to be the same for this. So I have 2 times 30 divided by, and again, you have to be careful, divided by 1/2 squared. So 2 times 30 is 60, and then it's going to be 60 over 1/4. But 60 over 1/4 is the same as 60 times 4. I can do that one in my head. 240. And this is the same, 240. So for this type of problem, again, it's a ranking problem. What's got the biggest force on it? Well, 240 is bigger than 112, so the ranking I would do here, C has to be equal to D, Newton's third law, and those two are bigger than A, which is equal to B. And that's the answer for this type of problem. So again, it's a conceptual problem with Coulomb's law on a line. And all you have to do is, since it's a ranking problem, worry about the actual numbers we're given. We don't have to worry about the K or the R values. Now, if you're more comfortable using numbers and actually getting the amount of newtons, you can just make up R and just make sure that that's half the distance. So that's the third type of problem that you might encounter. The last one, if I can get this erased reasonably, the last one is a conceptual one. So I'm going to give you different situations And you're going to have to figure out what's happening with the charges in those situations. Often it's going to be helpful to just keep track of where the pluses and minuses are. So the example I'm going to give you is with a couple different objects, and we want to know what the final charge on what I'm calling object A is going to be. It takes a little oomph to get this erased. Almost there, almost there. Okay, so fourth type of problem. We're going to have, let's say we have a rubber rod, and I'm going to rub that on animal fur, rub that with animal fur. So I'm going to rub a rubber rod with animal fur. And then the language I use for these problems is that the rubber rod has a stronger electron affinity. Stronger electron affinity. So stronger, bigger, electrons, negatives. Affinity means it likes them. Affinity is something you like. So a stronger electron affinity means it grabs the negative charges. So when we rub these two together, remember that we have three types of charging. You can charge by rubbing, in which case one becomes negative, one becomes positive. We can charge by touching, which transfers the same sign, or we can charge with induction, which gives the opposite sign. So in this case, we're starting by rubbing a rubber rod with animal fur. So that means that the rubber rod is going to grab the electrons. So we're going to have a rubber rod. It is going to get negative, and the fur is going to become positive. So now, my next step, I'm going to take the fur, and I'm going to charge, the fur charges an aluminum pop can. So the fur charges a pop can by the method of induction. All right, so we charge a pop can by the method of induction. What does that mean the pop can is going to get? Well, the fur was positive. So we have a positive animal fur, and it's charging a pop can by induction. Induction is the one where we get the opposite sign. So the pop can is going to become negative. So we have positive fur inducing a negative charge on the pop can. Third step, the pop can is contacted to object A. And this is the key for these problems. What is the end charge on object A? So is object A positive, negative, or neutral? So the last step, okay, we know the pop can's negative, and we're contacting it to object A. Contact gives the same sign, so object A is going to have the same sign as the pop can, is going to be negative. So in this case, the answer that I would be looking for, object A, is negative. So you're going to have a couple of these. One problem will be like 4 or 5 of this type of thing, starting really simple and getting more and more complex. But this is the way to think about it. Well, okay, a rubber rod is rubbed with fur. If the rubber rod has a stronger electron affinity, it's going to get the negatives, which means the fur gets the positives. And we take that positively charged fur, and we charge a pop can by induction. That means opposite sign. The pop can is contacted to A. Contact means same sign. A ends up negative. So that is another type of question for the C-level objectives for static electricity. All right, good job.